Afternoon, all my dear students. Today I brought you the topic of Unit 5 in the Industrial Chemistry, that is adhesives. So in this lecture, we should learn about history of adhesives, introduction of the adhesive material, its advantages and disadvantages, what's the adhesive action, and how many type of the adhesives are there. Students are able to understand about the adhesive materials, what's the principle of addition, advantages including disadvantages or we can say limitations of the adhesives, various types of the adhesives. So adhesive material go for using by the human, it's about 2 lakh years ago. The first reference to the adhesive in the literature first appeared in 2000 BC. The Greeks and the Romans made a great contribution to the development of the adhesive. In the Europe, glue was not only widely used until the period of 1500 to the 1700 AD, further than until 1960 the increase in the adhesive use and discovery were gradual. Only since last century the development of the synthetic adhesive accelerated rapidly and innovation in the field continue to be in the present also. So what are adhesives? These are those material which can be liquid or a semi-solid substances that has the capability to bind the other substances. Examples: cement, mucilage, glue. These are the examples of adhesives. The bodies held together by an adhesive is called adherent, means the metal or the material which goes on binding with the adhesive is called adherent, while the process of holding one adherent to the another by the adhesive is called bonding, and that can also be said to be a joint, which is a final assembly of two adherents and the adhesive, that is called joint. There are some other techniques of binding. Besides the other techniques, the adhesive are so important. Why? There are various advantages of the adhesives. The other techniques can be used as a swing, thermal bonding, mechanical fastening. Adhesives has the advantages over these techniques. The first advantage is ability to bind different material. This is only the ability of adhesives, not we can say the mechanical process or thermal process. Like metal on ceramics, ceramic on wood, plastic on the metal. So variation in the materials is there where we can use adhesive. That's the first most advantage. The second advantage is distribute the stress more efficiently across the joint. Means we can go for understanding the bindingness using the adhesive. It goes for evenly distribution there. The next important advantage is it is a cost effectiveness, that is cheaper. As compared to the other methods I have talked about, mechanical or a thermal or swing process, it is cheaper. In case of bonding, no high heat is required. Another advantage is no high heat is required. In thermal, high heat is required. In mechanical also, some way of the heat temperature should be given. So in the case of adhesive, no high heat is required. The process of applying the adhesive is very simple and does not require a number of highly specialized personnels. We do not require any other, or we do not depend on other to have a procedure using the adhesive. It is a very simple, anybody can use the adhesive. Bonding of adhesive gives smoother surface in the articles such as brake and clutch, facing or the aircraft assembly, which also be said improvement in the aesthetic design. Means it looks so smooth, it looks like original. When we apply the adhesive, no joint is appearing, seeing that two materials are different to one another. That is improvement in aesthetic design. By bonding together dissimilar metals with the adhesive, galvanic corrosion of the dissimilar joint is reduced by preventing direct metal to metal contact. So, for preventing the corrosion, sometimes two metals joining are there in the electrochemical cell. So there it in a electrochemical cell it is also called galvanic cell. So there, to prevent the corrosion, we can use the adhesive. Adhesive joints are leak proof for the gases and the liquids. So it is used in preparing watertight wood boards. So it acts as a seal there for the gases and liquids. Adhesive bonding require less after finishing as compared with the other process like welding, soldering. So as it appears a very smooth surface, it do not require much finishing as compared to the other process, binding. Now there are limitations of the adhesives because no method or no material are 100% perfect. So there are the limitations or disadvantages of the adhesive because most of the adhesives are the organic materials, so they cannot be used at a very high temperature. Their bond strength decreases as the temperature increases. So one of the disadvantage or the limitation we can say using the adhesive means we cannot use at a high temperature. The next disadvantage is it is relative weakness in the bonding of large objects with a small bonding surface area. If we have the large objects, big size objects, so it do not have that much bonding capability. So bonding can be taken, but it is very weak in that case. It creates difficulty in separating the objects during testing. So once you can use adhesive, it goes for binding it, and if we want to test it with some method where some separation is required, that cannot be possible using adhesive. If once you use, you cannot separate it. Only the plain and very clean surfaces can be joined for reliable strength by the use of the adhesives. Means this is the limitation, the surface should be plain and clean so that the bonding strength should be high. Adhesives often require appreciable time for their reactions of setting, hence they do not develop their full bonding strength immediately after the application, unlike the welding or the mechanical joining. So you cannot say the adhesive by the use of the adhesive immediately it goes for binding. It requires sufficient time or an appreciable time for binding. Immediately in you have your effect in some applications like welding and joining. Immediately when you do such mechanical process, the binding immediately takes, but it such can't happen in the adhesive. There is no single general purpose which can join all type of surfaces. Well, means adhesive cannot be used in all kind of surfaces we are having. So for a particular surface or a particular application, only a particular adhesive is required. Also, the particular bonding condition should be necessary. So for that, we have to go for selection. Now we move to what is adhesive action. So it is the tendency of dissimilar particle or the surfaces to cling to one another. All the adhesives contain polymers, or maybe the polymers are formed within the adhesive bond. The attachment of the surface by the adhesive is mostly due to the chemical or physical intermolecular force of attraction. Mean how they go for binding out two of the materials which are dissimilar to one another, or the surfaces are dissimilar. So how they go for the adhesiveness in that case, that is called adhesive action. It can be it is due to the physical or the chemical process, the physically we can say intermolecular force of attraction, which is also called the van der Waals forces, that is the weak force. And generally the adhesive which we using, it contain polymers, and they form polymers when they go for interaction with the other surface chemically. So that is the physical intermolecular force of attraction called van der Waals force of attraction. So we can say two type of the adhesive action can be possible. The first is mechanical addition and the second one is fusion addition. The adhesive may fill the voids or the pores of the rough surfaces and hold the surfaces by interlocking action, and this is called mechanical addition. When we have some of the depressions, pores are there in the surface, so when we apply the adhesive goes on filling on the gap or that pores, forming an interlocking action, that is called the mechanical addition. And fusion addition, in some cases the surfaces are partially dissolved in the adhesive, or its solvent or bonding of the surfaces takes place. So sometime what happened, the adhesive act as a solvent and the surfaces are partially dissolved in the adhesive, and on the basis of that the bonding is takes place. So two type of addition we can understand, either it goes like mechanical addition and the fusion addition. Now we go for understanding the various type of the adhesives in the classification. So the adhesives can be classified into 7 types. Here we have started the classification. The one most important adhesive is thermosetting synthetic resin, and the second one is thermoplastic synthetic resin. What are thermostatic synthetic resin? It forms a three-dimensional compounds with a cross-linked structure, and they cannot be reshaped, they cannot be remolded. So bond obtained with them is insoluble, infusible, and possesses good resistance to moisture, heat, insects, and fungi. For example, we have a thermosetting synthetic resin, that is bakelite, which is also called phenol formaldehyde resin. So it is a cross-linked structure polymer which cannot be reshaped, we cannot be remolded. Once on heating, it sets out and cannot be remolded. It's a three-dimensional compounds. So that are considered as it comes silicone resins is also the thermosetting synthetic resin. And then we go for talking about thermoplastic. It easily softens on heating and can be remolded or reshaped. They form soluble, fusible, and poor water resistant adhesive. The example of thermoplastic synthetic resin is the cellulose acetate or polyvinyls or acrylics. These come in the category of thermoplastic synthetic resins. The next resin are the natural resin, which can be found in the nature. The example of the resin is shellac resin, which is the oldest adhesive. It's a natural resin, and asphalt, it is also a natural resin. So their properties are very limited to use in the application. The next adhesive category is the starch adhesive, which is prepared from the starch. It is made by heating the starch in the water or dilute HCl at 150 to 175 degrees centigrade for a small period of time. So we can go for preparing the starch adhesives and can be use such adhesives in some applications. The next category is inorganic adhesives. Other than the carbon materials, we don't have generally all the adhesive contain carbon. Means other than the carbon, we have the another type of the adhesive that is called inorganic adhesive. The sodium silicate, it is an inorganic adhesive which can be suspended in the water forming gel and can be used as a adhesive. So that come in the inorganic adhesive. The next category is vegetable glues, which can also be said as a protein glues. So from the vegetable oil they go for producing, they are prepared from soya bean, corn, peanuts, albumin, which is a proteinaceous compound. So which are prepared by the soya bean, corn, peanuts, these all are called as a, it can be the extract of these vegetables which act as a glue in the extract. And the next classification is animal glues. It is prepared from the waste of the animals. It can be the bones of the dead animals, waste of slaughterhouses where the meat is there actually. The slaughterhouses where the animal meat we get. So from the waste of that slaughterhouse or the bones of the dead animals, scraps of the leather industry, because leather is also formed by the skin of the animal, that is snake. So the waste from the or the scraps of the leather industry also give us the glue. That is called animal glues. The example of the animal glue is liquid glue. Thank you. In the next lecture, we go on with the classification of the adhesives by some examples like thermosetting, thermoplastic we have understood. So one we have to go for example with its important properties like bakelite, silicone resins, or we have cellulose acetate. We have to take in all category, we have to take all the adhesives and its major application. So in the next lecture, we should go for the application part.